Hello everyone, in this video I'm going to discuss how to declare an arbitrary value and what does it mean to be a value and what number is an appropriate number for a value. And that will make more sense as I approach the end of this video. But first I want to point our attention towards a different method that you probably used in high school or middle school, right? So recall that when you were in high school or middle school learning about chemistry, you normally went about balancing chemical reactions with the guess and check method. And the guess and check method is a pretty good method because it works a majority of the time. And I mean, it works all the time, but sometimes it can be a very long process. But if we take a look at a chemical reaction, like this one, right, where we have hydrogen gas, oxygen gas, turns into water. So the combustion of hydrogen gas via oxygen turns into water. And let's say a teacher says, all right, go ahead and balance this reaction for me. And the first step most students would do is they would assign their elements on the left and right, and they'll write down how many times the element occurs. And they'll see, oh, it looks like hydrogen occurs 2 times on the left, oxygen occurs 2 times on the left, the reactant side, right? And we'll take a look at the product side and we see, oh, hydrogen occurs 2 times on the right, oxygen occurs 1 time on the right. And we can say that this is not good because this reaction is not balanced. Whatever we started with, we need to end up with, right? So if there's 2 hydrogens, we'd end up with 2, and that looks good. Oxygen, on the other hand, it doesn't look so well. So what you normally would do is you would multiply your product by 2, right? So we can get 2 oxygens, and ta-da, they're perfect. These 2 match. But unfortunately, right, this 2 times H2 becomes H equal 4, so there's 4 hydrogen atoms now, and now that makes it unbalanced. So what we do on this side is we say, okay, well, I need to accommodate for that change, so I multiply by 2 here, and we get a 4. Ta-da, they're all perfect. So the coefficients is 2, 1, 2. And look at how these are integers. These are whole numbers. So keep that in mind. Whole numbers for the coefficients. So let's talk about the arbitrary value. So the new method that we discuss is the algebraic method. And in the algebraic method, we need to declare an arbitrary value so we can determine the rest of our desired values. And so here I wrote out a snippet of the core idea, the basic idea of assigning a value. So pick a number, right? It's a number, a reasonable number. A reasonable number, what does that mean? Choose a number that's fairly small and not too big. So don't pick like 1,200, right? Pick a reasonable number, such as 1, to determine the rest of your desired values. So I'll explain what that means. So let's grab this idea and let's keep this in our head as we continue to the next step. So let's try the algebraic method on the same reaction. So go ahead and set up your letters A, B, and C to represent your sections. Go ahead and write that on the right-hand side. Right? The next step you want to do is you want to write out your elements. Right? I'm assuming you have some experience with the algebraic method with other problems, but that's okay if you don't. This one will cover it pretty well. Now let's take a look at how many times hydrogen occurs on both sides. So if we take a look at the reactant side, right? The reactant side, hydrogen occurs 2 times in the A section, right? Take a look at the product side. We can see that in the C section, there is 2 hydrogens, so 2C. Right? If we take a look at oxygen, it occurs 2 times in the B section. If we take a look at oxygen in the C section, right, it occurs once. So we write 1C, or we can just write C, right? Now comes the part where the main idea of this video, declaring an arbitrary value. And so it says pick a number, a reasonable number such as 1, to determine the rest of your desired values. Now, I'll show you what it means if we assign 1. So let's declare a value of 1, and we choose a variable. So A, B, or C. I'm going to choose A, right? So if we declare a value of 1 is equal to A, right? If 1 is equal to A, 1 is equal to A, that means 2 times A is equal to 2 times 1, right? Because remember, we just said A is equal to 1, right? So 2 times 1 is equal to 2C. What does that mean? Well, that means C is equal to 1, because 2 equals to 2C. Divide by 2 both sides, you get C is equal to 1. So if I said, let's make A equal to 1, right? That means I find that C is equal to 1, right? If C is equal to 1, right, and we look at this relationship to B, we want to find B. 2B is equal to C. Well, we said C was equal to 1, so B is equal to C divided by 2. But again, we said C is equal to 1, so that becomes 1 divided by 2, and B is 1/2. So I just solved the values, the coefficients, by declaring a value of 1 for A. And I'll show you different values in just a moment. But if you see here, we can say 1, 1/2, and 1 for the coefficients. As a scientist or as a chemist, we normally want to see these as whole number coefficients. So that 1/2 is not an appropriate value in terms of notation. It's correct, but we normally don't see it as 1/2. So we need to multiply this to become a whole number, and since this is 1/2, right, we multiply by 2 to get a whole number equal to 1. So that O2 therefore becomes a 1. And so if we multiply this one by 2, we have to multiply everything else by 2. And so we get 2H2, right, plus 1O2 is equal to 2H2O. And that was the same answer we got up here. Okay, now I know I'm kind of avoiding the question of, okay, what is an arbitrary value? So let me go back to that idea. Let me erase all this first so it won't confuse anyone. Okay, let's see if I can erase the bottom down here so it won't be as confusing. Alright, sorry, this purple's not going away. Okay, declare a value. Right, so I just assigned a value of 1, but let's say I declare a value of A is equal to 2, right? Remember, an arbitrary value it can be any value. It's a random value, but it's reasonable. I won't choose a value such as like 100,000. That's impractical, right? You want to choose a small number you can work with. And if I chose a value of A is equal to 2, right? So if A is equal to 2, then if I take a look at this equation, 2 times A, which we said was 2, is equal to 2 times C, right? So 4 is equal to 2C. Then C must be equal to 2. Remember, we said A is equal to 2 and C is equal to 2, right? Well, let's take a look at here. Now I want to find B. 2B is equal to 2C. Divide by 2 both sides. All right. Oh, no, I'm so sorry. Please ignore that. That's incorrect. What I meant to say was that 2b is equal to c, right? And what did we say c was? We said c was equal to 2. So 2b is equal to 2. Divide by 2 both sides. You get b is equal to 1. Ta-da! You have your coefficients. And what do you know about them? They're all whole number, so it works out pretty well. It's quite amazing, right? And so that's the same answer of 2, 1, 2, 2, 1, 2, right? So it's perfect. So we just declared a value of a equal to 2, and this one works out. In the previous one, we said, oh, let's make a equal to 1, and it worked out, but we just had to do an extra step. Now I want to show you another way of declaring a value, a different number, right? So if I said, sorry, erasing is taking a while. Get rid of the purple. Okay, let's get purple. If I said a is equal to 4, right, as an arbitrary value, right? So pick a number, a reasonable number such as 1. In this case, I'll choose 4 because it's pretty reasonable. It's pretty small. It's good to work with. If I said a is equal to 4, 2 times a, right? 2 times 4 is equal to 2c. That's 8 is equal to 2c. 8 divided by 2 is equal to 4. So that means c is equal to 4. So when a is equal to 4, c is equal to 4. Right? If b is equal to 2b is equal to c, right? We want to solve for b, right? So 2b is equal to c, which is 4. So b is equal to 2. Right? B is equal to 2. B is equal to 2. And we say, oh, that's correct. We can write it down as 4, 2, 4. But there's something wrong with this. And what's wrong with this is that it's not simplified, because we can simplify this down further. Divide by 2, and we get 2, 1, 2, right, for the value. So 2, 1, 2, and that is correct, just as how we looked at the previous example with guess and check. And so remember, when we declare a value, I think this is the hardest part in my opinion, declaring a value, because we're so used to doing a very rigid process. But sometimes in math you have to start with givens. You have to suppose something. So like saying, I suppose that a is equal to 4. We're declaring a value. And so that would be the hardest part. And so I hope this helped with the idea of declaring an arbitrary value. If not, let me know in the comments if it was helpful or not. But I suppose this is a good way of seeing that the value can be anything, okay? You just have to make sure it's a reasonable number, right? It can be 1, it could be 2, it could be 3, it could be 4, but if you're choosing a million, I mean, it could be a million, right? But you would be working with such big numbers that it would be unnecessary, right? And so, you should try it out with different numbers. Try it out with maybe 3, a is equal to 3, or you know what? You can even try it with b is equal to 3. So if you said b is equal to 3, then you solve for the rest, right? You're essentially assigning a value to any variable of your choosing. Let's say if I made b is equal to 1, right? If b is equal to 1, 2 times 1, right, is equal to c. So c would be equal to 2, and b is equal to 1. 2a is equal to 2 times c, but we said c was equal to 2, which is 4 is equal to 2a. And a would therefore be equal to 2. And that works. 2, 1, 2. So just get comfortable and practice. And I'm sorry if I wasn't helpful, and I'm sorry that this video took 15 minutes. So please enjoy and good luck.